This video provides information on shear stress analysis in PC-Convey. The shear stress calculations have been primarily written and checked for cross-sections having shapes like those designed using PC-Convey's constructed waterway designer. Results will be provided for other cross-sections, but as for all PC-Convey results, it is the responsibility of the user to determine fitness for purpose. To demonstrate calculating shear stress in accordance with industry practice, we'll use a cross-section created with the example on page 118 of Melbourne Water's Constructed Waterway Design Manual. This cross-section file is included with PC-Convey, and you can see how it was created in the video Creating a Cross-Section Using the Constructed Waterway Designer. Paul Du Bois' 1879 equation for shear stresses on a trapezoidal cross-section is used to calculate unfactored shear stresses. As well as factored shear stresses, PC-Convey can display unfactored shear stresses for comparison to HEC-RAS, which doesn't calculate factored shear stresses. The results are practically identical, as shown here by these main channel results and these overbank results. PC-Convey uses work published in 1970 by the US Highway Research Board in accordance with industry practice such as that shown in Melbourne Water's Constructed Waterway Design Manual. These graphs are used to obtain values to factor up the side and bed shear stresses. From version 13 of PC-Convey, average shear stresses are now shown by default, but the maximums option from version 12 is still available. When the cross-section is on a bend, the default shear stress factoring method is in accordance with the diagram from the US Department of Agriculture Natural Resources Conservation Service Manual 2007. This is the same diagram recommended by Melbourne Water in their Constructed Waterway Design Manual. This method is termed the USDA NRCS approach in PC-Convey. The HEC-15 Plus approach from version 12 is still available and is the only approach where it is necessary to specify whether erosion of the waterway would be a high risk to life and property. Otherwise, this part of the form is not used. Work by Ippen and Drinker in 1962, as well as by others, shows that shear stresses also increase on the inside of bends, and in fact the highest factor that they found from 13 laboratory experiments was on the inside of a bend. Integrity Software developed an approach for factoring up these shear stresses, and this is termed the IDNTIS approach in PC-Convey. See PC-Convey's help for more information on this. Melbourne Water doesn't require these shear stresses to be factored up, but other authorities may decide differently. Substantially more information on the pre- and post-version 13 approaches to factoring up shear stresses is available in PC-Convey's help. This help file is available in the demo version or can be individually downloaded from our website. If you have any questions or comments, please leave a message below or contact us through our website. And thanks for watching.